Hi, welcome to Talking Tech. I'm your host, Marcus Yam, and like many of you, I'm a big fan of the Intel NUC. In this episode of Talking Tech, we're taking a deep dive into Raptor Canyon, the latest extreme NUC built around an all-new compute element, at the heart of which is a 13th gen Intel Core processor, codenamed Raptor Lake. Officially called the Intel NUC 13 Extreme, which we will refer to in this video as Raptor Canyon just because we love codenames, and it features an innovative top and bottom design to allow for maximum free airflow to both the CPU and GPU, the latter of which can now be as large as a full-length triple-slot graphics card. In keeping with the Intel NUC design philosophy, it's maximum performance in minimalist packaging. To tell me more about that is Faisal Habib from Intel, the Intel NUC group. Faisal, welcome, and can you tell me a little bit about who you are and what you do at Intel?
Absolutely. Faisal Habib, I'm the enthusiast marketing director for the NUC group. I look after all of the extreme and enthusiast product lines that we have been producing over years. This is the 10th year of NUC, so it's been an interesting journey up till now.
A decade of NUC.
Yep.
And how long have you been a part of this journey?
Fortunately, unfortunately for all of it. So yeah, I was here for the first one, Ice Canyon. So it's been an amazing journey.
So you've seen the NUC grow up, right? we started off, everyone still thinks of NUC, even though we've got many different types of NUC now. That original 4x4 form factor where you packed in kind of like, you redefined what it means to have a desktop,
right?
A small little desktop. But of course, that's capability that's grown over the years. So can you just walk me through how we started from 4x4 and how we got here?
Yes, absolutely. So, when we started the journey for the NUC product line, it was trying to make the smallest possible form factor without compromising on performance. That continues to be our ethos across our product line. So we've continued to grow in the various form factors and driving towards different vectors for different segments, but ultimately it still continues to be focused on miniaturizing performance in the smallest possible. So while the form factors have increased, it's also delivering a lot more performance per liter, shall we say.
Now over there on the shelves, I know we have some of those other form factors that you're mentioning.
Absolutely.
So let's take a look over there.
Absolutely.
All right. Okay. So here we have a few of the previous generation NUCs. Yeah. Walk me through. I know we got some enthusiasts on the left, some extremes on the right. What are we looking at?
Yeah, so to kind of paint the story, we'd have to take one more step further as when we went down this journey with Hades Canyon, as you may remember, which was the first KB Lake G based NUC, which had integrated graphics.
Discrete
Graphics, yeah.
Yes.
So that one, the market really adopted, and there was a lot of interest in that small form factor and graphics performance. So we evolved it to become Phantom Canyon, which was our 11th gen CPU with NVIDIA's 2060 graphics, which continued the form factor conversation, which we further evolved this year to the 12th gen version with Intel's own graphics. So we continue to focus on that enthusiast line to deliver the smallest possible form factor for gaming performance. So that continues to be the line. But then we transition to our extreme product line where our customers have continued to ask us for, we want small, but we really want the next click up of performance. So we created a product called Ghost Canyon, which was focused towards enabling desktop card capability. So there's a PCIe slot in them. So that swim lane continues to extend, which is where we are today, to continue to deliver the highest end of desktop class performance.
And that was, I guess, when you're looking at increasing performance, both processor and graphics, as you said, at some point you're getting into the discrete add-in card GPUs. And of course that was Ghost, which I love, the 5-liter chassis. And then that evolved into Beast and Dragon. And it looked like those are the form factors of those were very tied to the size of graphics cards at that point.
Absolutely.
So you went from your 8-inch graphics cards to your full-length graphics cards. So is it graphics cards that have been one of the main drivers of the form factor changes? Looking at Raptor Canyon here.
Absolutely. Again, we want to continue to deliver the ethos of the best possible performance and small form factor. And as the graphic card industry evolves towards delivering more performance, which results in a bigger size or footprint for the graphics cards, we are having to evolve as well to kind of drive that. But it still delivers the smallest possible form factor for that kind of performance.
Now, it looks like there's also been changes to the compute element with a larger size. This is the compute element that was found in Ghost, Beast, and Dragon, which is the previous gen. Okay, and this kind of reminds me of the old slot Intel processor. When I saw it, oh, you're putting a processor in a slot. I've seen that before, but there's a lot more integration going on here. So can you kind of recap the engineering effort and the features that went into that? And of course, we got to get to. It looks like you're taking advantage of a little bit of extra space there.
Yeah, you're also aging yourself when you talk about this card. But,
Celeron 300A for life.
So, we started with. We've always tried to stay with industry standards. So when we designed this element, we were going with the PCIe by 16 connector, which worked well, and it led to many interesting usages from the industry. Where recently we've seen people start doing PCs inside PCs for creator kind of usages, which have been interesting. We've also seen some customers start to create like edge servers with these units, putting them into blade-like configuration. So it leads to different innovations, but ultimately we did it to enable the smallest possible gaming desktop. Now, as to continue to deliver that, our customer feedback has been, it could be made easier. There are too many wires. There's still an ease of integration challenge there, which we could take on to resolve. So as we went into the 125 watt processor space, we also enabled keeping that ease of integration goal in mind, a extender on the element, which continues to be the PCIe by 16, but there's more, which plugs in power and other connectors through it. So there are less wires you need to connect at the top, which makes ease of integration a focus area for us.
I also know that on the jump from 11 to 12 to Alder Lake, you went to a socketed CPU. And I know that that's carrying over to Raptor Canyon too. Can you tell me more about the decision to go from soldered to a socketed?
Absolutely. The direction for soldered to socketed was primarily for performance reasons. Our goal continues to be deliver the best possible performance. The best possible performance from an Intel Silicon roadmap perspective is in the socket CPU space. So therefore, we followed that to adopt a socket. It wasn't for creating a new motherboard standard or anything like that. It was more to deliver that performance levels in our PCs.
And you just said it, the motherboard standard. So anyone looking for a small PC, is there, when I think about people who want to DIY their own small PC using maybe a mini ITX, mini ATX, is there like innovation still that exists in between something that's tightly integrated and soldered compared to socketed? Now here, where is the innovation space there?
So there's still a lot of innovation to be had between these form factors, but ultimately, Intel provides choice, right? So we provide all of these systems to continue to deliver the best possible performance in small form factor, but there's a whole market out there for bigger, different size chassis for different kind of innovation. But we are also enabling a lot of innovation through our ecosystem partners, from chassis to cooling solutions to many other things. We have customers are already looking at taking our elements and making water-cooled solutions out of them, so we can provide the same level of innovation in desktop for DIY partners.
So, ecosystem.
Yep.
That seems to be the perfect segue to actually talk about these options on the bottom. Can you?
We have had several partners over the years continue to create chassis and ecosystem options for our elements. Two of them are here. Cougar and Akasa have been creating chassis, a variety of different form factors. As you can see, we went for a slightly taller kind of design. They're providing choice by going wider, but they all support full-length graphic cards and options. Akasa even went further to provide a water cooling solution as well. So there's going to be many more partners coming out over the next couple of months, but the ecosystem is where we thrive. We try to create more choices.
And it's, choice has always been one of the hallmarks of why people would build their own machines. So for someone who is looking at exploring, they want a small PC that's easy to move around, would fit in any sort of variety of spaces, whether at the home or on the go. Who is Raptor Canyon for? Whether it's in this chassis or the other ecosystem chassis, how would you sell it to someone? Should I build my own PC or should I start with one of these?
I think the Raptor Canyon and most of our kits are in a sweet spot between customers who may not have all of the desire or expertise to do a full DIY, but still want the choice of components to deliver, that perfect system for themselves. So our kits give you that opportunity to do that without compromising on any of the performance, because we've done all of the engineering work to deliver that highest performance, best acoustic levels that they would want. We still believe this is the smallest form factor to achieve this kind of performance. But it is less a transportation kind of or easy to carry around kind of product than our previous generations. But we do continue to provide other products that fit those needs. So there's choices there from our product lines, but this is solely focused on delivering that highest possible performance on your desktop.
And actually, something else I thought of was you're talking about design, right? Like what you guys design for. Are there any overall design philosophies or guidelines that you think about when you're designing, at least on the Intel engineering side? Is there anything that you think about for noise or thermals that are kind of consistent throughout all the design? Yeah.
So the ethos for all of the products that come out of my team has been uncompromised performance, right? So we kind of drive to performance first, kind of show the best of what that can be, and then form factor. The vectors slightly modify for our enthusiast line, where it's more about smallest possible first, then performance, versus the extreme line, which is performance first, then smallest possible. But we obviously also continue to focus on acoustics a lot, primarily because our PCs sit on the desktop, not below it. So it's closer to your ear. The fan curves, the noise, all can affect your experience. So we spend a lot of time engineering to that.
And I have to say, they are very quiet perform pieces, and mine definitely does sit on the desk. Talk about consistency across the line. I have to point out, the skull has been a part of the NUC for quite a while. I mean, you can't see them because they're not on right now, but they kind of glow and you can customize them. And I know that there's no skull on the chassis on Raptor Canyon. So where's the skull? Where'd it go?
Yeah, the skull is still there. I would say the skull is on the heart of the machine now. But the skull has been an interesting journey for us over the many years of using it. It's pretty divisive. Some customers love it, some don't. We've usually enabled choice from that perspective in terms of providing a skull which you can turn off so that you can choose how to do it. But we've changed some of our customizability opportunities on the Raptor, where it's more headers and other ways of customizing, like you would do with a tower or a PC, which are slightly different. So it'll be interesting to see how it plays out. But no, we haven't walked away from the skull yet. That's absolutely still on our PC, but slightly less in your face.
Okay. The good thing is I do see that the third-party chassis does still have the skull, but I know I kind of like to make things my own, and for a very quick way to mod the machine, since it's magnetized, I'm just going to customize a little bit. And if you want to have another idea for how big this thing is, there's a banana for scale. But I think that's a bunch of fun. But we'll have a look at some point to see what a real modder can do this machine. So,
absolutely.
So Faisal, thank you so much for walking through here, and we're going to do a little deep dive with Ray. But thanks a lot for your time.
No problem. Thank you.
Thank you. All right, Ray. Thanks for joining me again. Last time you showed me Dragon. This time you have Raptor. But who are you? What do you do at Intel?
I'm Ray Washington. I am a technical marketing engineer. I work on the enthusiast and extreme product lines, namely, previous products, Dragon Canyon, little bit on Serpent Canyon, but primarily for this video and for all the information here, Raptor Canyon.
Let's dive in.
Yeah, so Raptor Canyon, as Faisal so eloquently put earlier in the day, it's our 13th gen extreme product. We set in motion kind of an intent to go up to the unlock SKUs. So we have all the way up to a 13900K SKU platform. We designed this chassis intentionally to optimize around the thermal capabilities of the right amount of gaming performance to get the most out of the chip, but also to remain very quiet and to have it be cooled, entirely air-cooled for one, which is very difficult in a small chassis. This is around 13.9 liters. but also, just to give that kind of uncompromised performance.
So everyone wants to see what's inside. You want to mention, or you did mention like air cooling, airflow. I see there's kind of mesh panels in every direction I can see over here. But yeah, let's see what's under the hood.
Yeah, and to kind of very quickly about mesh, the reason we use mesh is because it does allow for a clean, front to back or right to left kind of airflow design. Specifically for this one, we tried to focus on around a 70-ish% open ratio, which is important to make sure that the air doesn't get restricted when going through. But to get right into it, we have a exchanger that is roughly 110 millimeters tall by 92 across, which is where the brunt of the heat goes from the system. It's actually air comes from this kind of an open air test bench, flow through design, and gets exhausted out the back through a 120 millimeter fan that's kind of guided with some shrouding to encourage the air to go through the areas that we want. As an additional for kind of like the little bit of extra peak performance, we have another heat pipe that comes up to this blower fan exchanger, which does actually contribute to additional cooling. We see probably around 25 to 30 watts of additional cooling that's provided by just this upwards exchanger. And to kind of show how this works, we are also, our design is focused around, as I said, kind of exchanging the air as quickly as possible. The air comes in from this front side where the main CPU board is, and the GPU is also kind of focused in that side as well. And then we exhaust out of these two 120 millimeter fans. This is a chambered design, so the top portion of the chassis is actually completely separated from the bottom portion in terms of where the thermal production of where the wattage is being used. The GPU does not preheat the air coming to the CPU, and vice versa. The CPU doesn't contribute any thermal waste to the GPU.
And that was this top and bottom design. That's a big change from Beast, Dragon, where you did have some heat mixture going on between the blower on the element right up against.
Yeah, and on Beast and Dragon, we kind of tried to do as much as we could to give the CPU a direct airflow path. We had that air guide, which separated one extra PCIe slot between the CPU board and the graphics card solution that, for a dual slot solution. This we can support all the way up to triple slot. Our power supply is a 12 VO solution, so it's really optimized for those low power usages as well. Very much more efficient at the sub 5% CPU utilization, which a lot of systems will sit at when they're, when you're just at Word documents or in YouTube, those kind of things that a lot of people will just relax with. Nobody's relaxing with Word, obviously, but YouTube. It goes to a very low power utilization, and it's entirely designed around that. For the purpose of, integration, again, with Beast and Ghost and Dragon, to get back into the CPU and memory, you did have to remove the graphics card, which we, as Faisal said earlier, that didn't lead to a very good integration experience. With Raptor, you do not have to touch anything in the upper chamber to remove a graphics card. It's entirely toolless to get to the chamber to be able to do that in the first place.
Let's flip that around so people can see just the separation of the top and bottom. So let's turn it.
Oh, yeah. I can turn it right back around to kind of show that.
And other question about the mesh. You're talking about the airflow.
Yeah.
I run on my desktop with like a wet bench, and I love it being open. It's also kind of lazy, easy to upgrade.
Yeah.
So how does this open case, some people just run an open case, is there any benefit to having all these panels off like we see for airflow in such a small form factor, or does it not really matter?
In terms of thermal performance, we've actually done quite a bit of testing around that. And what we see is that because our panels are so open, they're a mesh structure designed to kind of protect the system, both from electromagnetic interference, but also for people not getting their hand into a fan, those kinds of things. But in actuality, there's not a lot of performance difference between running this with side panels on to protect it, as well as side panels off in an open chamber. You get very slight amounts. You can do some interesting things like, modding with an extra fan on this exchanger. That's actually what this area right here is on for. That's actually a 92 by 92 mount, which helps some of our ecosystem partners be able to add additional cooling where they may not be able to do a design that's separated into two chambers like this.
When people see a lot of fans, right? You got
Yeah.
GPUs will make their own noise, but from the NUC team and Intel design perspective, what are the noise targets, and kind of where does this one fit in?
So we can't control what the graphics card solutions do, but the fans that are included in our system, we believe they're fairly optimized, and we don't expect end users to have any type of poor experience with those. They should be very well expecting a great, very quiet experience.
I'm glad you have the panels off here, because I think that when you're looking at this NUC being the size that it is, people think that, oh, it's just so big and there must be a bunch of empty space in there. But looking at it, looks like there's still a lot of tight integration. So can you walk me through kind of the other features and integration of things in here? Maybe it might be beneficial if you wouldn't mind to take the element out and we can kind of see what's
sure.
there.
So we've kind of pre-prepped the system. There's only 3 screws that are necessary to take the element out. And then we have one cable that is for the front Type-C. Type-C has a very low margin in terms of noise and signal quality. So it was the one thing we had to keep cabled. Unfortunately, it couldn't run through the baseboard. But if you look at that solution, we have a small PCIe latch that allows it to push down the standard PCIe retention latch. And that's obviously hooking into this structure right here. As Faisal mentioned earlier in the day, a lot of our signals are coming through this additional header here, this additional PCI Express, what we call the extension by 4. All of the power for the element comes through this one header right here, which is a 12 volt, rated for about 40 amps of power, this little gold tab. And then this extension header has 2 SATA signals, 2 PWM TAC signals for additional fans, 2 additional USB 3.0 ports. And then it has some unused signals that we may use at a later date, but they're exposed for our chassis vendor people that if they want to use it, they can.
So as we saw earlier, the jump from the previous element to this one, you kind of have the luxury of a little bit more space now. Are there any new innovations that the team took advantage of with the extra real estate?
I mean, from the integration perspective, it is DDR5 now. It's still SODIMM. Just from a size perspective, standard DIMMs would have extended the board height to probably close to an inch further tall than it is today.
Cooling looks like it's...
Oh, the cooling is much more robust.
Much bigger, yeah. Even you see the
we have a very tight... so if you were to look like a third-party CPU heatsink, their fin pitch is going to be nowhere near as tight as this. Because they have to allow for fans to be in an open situation. We're guiding the air through, like I said before, setting that down. The majority of the thermal exhaust goes directly through this exchanger and it gets pulled into this kind of area right here. We provide a little bit of additional cooling for the 2 M.2s, which we anticipate are going to be the most likely to be used. This is the CPU attached one, and then we have another one that's NVMe as well. We do support 3 all at the same time. The chassis also has, like I said, for the SATA signals, it also has the ability to mount and control 2 2.5-inch drives or an additional 3.5-inch drive without sacrificing any other thermal performance in the system.
So can you do the math for us? What is the maximum topped out configuration you can have in both terms of memory and storage?
M.2s today go all the way up to 8 terabytes. So you could have 24 terabytes of M.2, 2.5-inch drives top out somewhere in that same range. Yeah. You could get up to 40 terabytes of solid state storage in this system. And then memory, we're limited to 64 gigabytes of DDR5. POR is 5600, but it can go with XMP. You may see higher with additional vendors in the future.
Wow. So, I mean, not only for gamers, but creators who need a ton of storage. What about connectivity? I know that there's a whole bunch in the back. Is there anything new, different, something that you want to call out?
No, we got really good feedback from the existing Dragon Canyon platform. So we have the same 6 USBs that are 3.2 Gen 2, so 10 gigabit ports. We have dual Thunderbolt, same as we did on Dragon. We have a 10 gigabit Ethernet and 2.5 gigabit Ethernet, same as we had on Dragon. We did go with external antennas. Reason being for that is from an integration perspective, having to remove internal antennas kind of is a little fiddly, and it was one of the things that a lot of people complained about. So we've swapped to external. It is now Wi-Fi 6E, the killer Wi-Fi 1690i, which is equivalent to a Wi-Fi AX411. And then we have rear audio, which is provided by a Realtek ALC 1220. And then we also have front panel audio on the chassis, which is a Realtek ALC 4050.
Any other cool new features that the DIYer may appreciate?
We've switched entirely to desktop type headers. So the internal headers off of the chassis are standard desktop 4-pin fan headers. Even on the Element, they're the standard PWM. So what you would get on a standard case fan from a Noctua or a Be Quiet or any of those guys, standard headers for that. In terms of other integration stuff, we do have RGB headers on the baseboard, which are controlled. They're addressable RGB up to 30 LEDs per header. They are controlled by the NUC Software Studio software that we offer on Intel.com as well as on through the Microsoft Store. And while we don't have RGB on the chassis itself, we've been able to use it with, like I said, the same thing, like Be Quiet RGB fans work great with it. We also have tested it with some of the third-party RGB chains that you can get on Amazon. The strong limitation being if it has more than 30 LEDs in the chain, past 30, they're just not going to function because that's what the controller is designed to allocate.
Yeah, well, there looks like there's a lot of options for modding and kind of personalization. So, hey, thanks so much for this walkthrough. We're going to have you do a little bit of a build time lapse again, like we did last time. That was super cool. So we'll do it again. But for now, for this walkthrough, Ray, thanks so much.
Yeah, no problem.
That was Talking Tech on Raptor Canyon, the brand new NUC featuring the 13th gen Intel Core processors codenamed Raptor Lake. We had a really great look at both the outside and insides of this. We also talked about customization, modification, really making it your own. So coming soon, just gonna tease this right now, there's a modification in progress and we'll be seeing that in a future installment. So stay tuned to the Intel Technology channel where you'll be seeing more of that. Thanks for joining Talking Tech.